Hi, I'm Yannis Roussos, the product manager of the memory group, and I'd like to take you through what we're planning to achieve in GitLab 14.9, which is scheduled to be released on March 22nd of 2022. Before I continue with our planning, I would like to provide a very quick background on what the memory group does. Our main goal is to continuously identify the bottlenecks that affect GitLab's performance and availability and address them, either on our own or in collaboration with the teams that are directly responsible for those areas and have the domain-specific knowledge. We also work towards providing better tooling, metrics, and visibility to development teams with a goal to allow them to make better data-driven decisions when developing new features or iterating on existing ones. So on our top priorities for 40.9, first of all, is working on continue working on performance-related tooling. As already discussed, we want to enable every GitLab team member to make data-driven decisions and understand performance-related issues, memory consumption, or CPU saturation events that require sharp tooling and clear, simple to understand performance guidelines. So in 40.9, we will continue with working on consolidating our profiling tools. We'll provide an extended set of tools for performance profiling with overlapping functionality and sometimes no clear guidance on when and how those tools should be used. So we plan and we want to condense them into a more manageable tool belt and provide clear, well-defined guidelines for developers. So in 40.8, we have already reviewed a lot of tools. We have decided to keep some of those. We have archived or removed some others, and we want to continue doing so in 40.9 and cover all the tools that we provide inside GitLab. We have also deprecated the request profiling, which is a feature available for GitLab administrators. It will be removed from GitLab in 15.0. This is a feature that the profiling provided by this feature is partially already covered by in our performance bar. There is one missing part, which we also work on moving it to the performance bar, the memory profiler. This is a feature that we have enabled starting on 40.8, but at the moment it's only enabled for development environments because we have some security concerns about profiling production workloads. We will keep working on it, review it, and make and decide whether we can also enable it for production environments so that it's also available for GitLab instance administrators. Finally, in 40.9, after we consolidate all our tools, we also want to work on our tools, profiling tools documentation and our guidelines, and provide clear, easy to understand guidelines that will explain, for example, if you have that symptom, how to verify it, what tool to use to start working on it, how to interpret the results, how to make a decision, etc., etc., etc. And our next top priority is improve the efficiency and maintainability of application metrics exporters. So we have a lot of metrics that we gather in various components of GitLab, either on background workers, Sidekick, or on our web servers, Puma. And we want to review our approach for serving application metrics in general and exporting them to Prometheus. So our target there is to make the whole process more reliable and more stable and fix a few issues and of course more performant. So our plan in general for this initiative is to implement a new integrated way of exporting metrics that provides a single application exporting system. At the moment, we have more than multiple ones, runs outside of the Rails monolith, and performs efficiently in the face of large data volumes, tens to hundreds of thousands of samples per scrape. So we have, in the context of this initiative, we have already in a past version completed exporting the Sidekick metrics to a separate process. Sidekick metrics are the background workers. And now we're looking into extracting the metric servers also for Puma, our web server, into a separate server process so that we can improve in general fault tolerance and GitLab availability. So our plan in general is to separate those processes so that we can then find ways to integrate them into a single process. So this specific endeavor for the Puma is in response to incidents we have seen in the past, where the in-process rack server, the one that is responsible for sending the metrics, can lock up the entire process and cause Puma to lock. So this is what we are going to work on 14.9. Once we have extracted all those metric servers, the next step in future versions will be to replace them with a single exporter system. And we have already, in a past milestone, created a prototype in Go, which behaves more or less like what we have today, but it is 80 times faster while using a similar amount of memory. So this is a good indicator that we will move our exporters to using Go, to use this new prototype. But this is to be decided after we finish our work on moving the metrics out of the Puma priority. Our third top priority is optimizing workers that consume a lot of memory and can cause out-of-memory kills. So we have, in GitLab.com, we are seeing more than 1,000 workers killed per day due to out-of-memory events. Our assumption is that the Linux out-of-memory killer is killing our workers as the kernel is not able to fulfill a request to allocate more memory. So we have, during 14.8, we have investigated the top offending workers, and we have found a few that sometimes can consume more than 1 gigabyte of memory. So our plan is to is to work on optimizing several of those top offender workers. We will start with a coverage report worker on 4.9 and work through all of them. Our goal is to reduce this memory consumption, and hopefully we will reduce the number of workers that are killed due to out-of-memory events. Finally, our final top priority is the composable code base. This is the way we call the project of splitting the GitLab application into functional parts, into application layers, so that, for example, using Rails engines or something like that, so that we can ensure that only the needed code is loaded each time. This is very important. This is a very big project, so we are still evaluating it. But if we were to do so, that will result in lower memory usage, even up to 30%, shorter application boot up times, even up to 20 seconds faster, and improved responsiveness of background workers due to much shorter garbage collection cycles and much more. If you are interested in the link, there are more details in the linked epic and the additional issue where we have a lot of more details. But this is a very big project, so we are still evaluating it. In 14.8, we have identified the impact. We have started working towards identifying the impact of composable code base and the additional performance benefits that we'll be able to achieve with initiatives that may depend on it. I'm really sorry. And we plan in 14.9 to continue working on that and continue our cross-section or cross-department discussions with other groups, because this will affect all of GitLab, and have a final proposal during 14.9. That's it for our plan for 4.9. Thank you for watching, and talk to you on March.